Day 661 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1544, make the string great. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a string S of lower and uppercase English letters, a good string is a string which doesn't have two adjacent characters S of I and S of I plus 1, where 0 is less than or equal to I and I is less than or equal to S dot length minus 2. S of I is a lowercase letter and S of I plus 1 is the same letter but in uppercase or vice versa. To make the string good, you can choose two adjacent characters that make the string bad and remove them. You can keep doing this until the string becomes good. Return the string after making it good. The answer is guaranteed to be unique under the given constraints. Notice that an empty string is also good. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. Now, we're in the middle of doing about a month of easy strings, so if you want to get caught up on your strings, you could check out the previous problems or just stick around and keep coming back day after day until for the next probably 20 or so days while we finish up this month of easy strings. Now let's get into this example. So in example 1, our input S equals a string LeetCode, but as you can see, it's L lowercase e, capital E, lowercase e, T, C, O, D. The output is LeetCode. As you can see, we remove these two characters right here because it says to make the string good, you can choose two adjacent characters that make the string bad and remove them. These two characters make the string bad. Why? Because it says a string is good, or a good string is a string which doesn't have two adjacent characters, S of I and S of I plus 1, where S of I is the lowercase letter and S of I plus 1 is the same letter but in uppercase or vice versa. So right here, this is the same letter, uppercase or lowercase, vice versa, or we could do these two. It doesn't really matter. Either way, we have to remove these two E's or these two E's, but either way, two E's need to be removed. One of those E's needs to be uppercase. Boom. After we do that, we're left with this LeetCode. Explanation says in the first step, either you choose I equals index 1, which is this index, or I equals index 2, which is this index. Both will result in LeetCode to be reduced to LeetCode. So, boom. Let me just check it. 1, 2. I don't know what they mean by this. You can either choose I equals 1 or I equals 2. This is 2. I don't know. But either way, after we remove these two or we remove these two, we're left with this. Boom. So just in case that didn't make sense, let's take a look at example 2. So in example 2, I'm going to copy and paste this over here because we're going to need a better visual representation of what's going on. So in example 2, we have our input S equals lowercase a, lowercase b, uppercase a, lowercase c, uppercase c. Our output is a blank string. So let's see how we got that blank string from this, right? It says we have many possible scenarios and all lead to the same answer. So let's go through it. It says, boom. So first we can remove these two B's. After we remove these two B's, boom, we're left with this. Now this isn't a good string either, right? So after we're left with this, we can remove these two A's because this is lowercase, this is uppercase. Boom, we can remove it. Boom. Then we're left with this. Boom. After we remove this, then after we remove this right here, then we're left with this. Boom, or this. And this is just another way we could do it. First, we could remove the two B's. Then we could remove, or excuse me, first we could start off removing the two C's. Then we could remove the two B's. Then we could remove the two A's. And either way, we'll still be left with this or this. So that's how we got this blank string for example 2. Now let's take a look at example 3. So in example 3, we have our input S equals a string S, and there's only one character, so the string is already good. So since the string is already good, we could just return that same character S, right? Because there are no two characters of the same letter with one uppercase and one lowercase, so we could just return it as it is. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. So first we're going to create a stack that will hold the characters that form the good string, and we're going to use it to simulate removing adjacent invalid pairs. So we could just declare a variable called stack. We'll say colon. It's going to be an array characters. Come outside of that, and we'll initialize it with a blank array, just like that. Boom. Now we're going to iterate through each character in the input string by saying for char ns. Boom. Now we're going to check if the stack is not empty and see if stack that by checking if stack.last exists. Then the last character in the stack is not exactly equal if the last character in the stack is not exactly equal to the current character, but their lowercase versions are equal, then this means they are the same letter but different cases, right? So we're going to check this by saying if let last equals stack.last, then we're going to open up we're going to say, not open up the brackets yet, we're going to say equals stack.last, comma, last exclamation point does not equal char, and two and signs, last dot lower case parentheses equals char dot lower case, put the parentheses. Then we're going to open up the brackets and we're going to remove the previous character from the stack, and this effectively removes the bad pair. So we're going to say stack dot pop last. Boom, put the parentheses. Then we're going to come right here, we'll say else, open up the brackets. Otherwise, we're going to add the current character to the stack because it does not form a bad pair. We're going to say stack.append, open up the parentheses, pass in char. Boom. Then we're going to convert the stack back into a string and return the result by coming down here. We're going to say return string, open up the parentheses, pass in stack, y'all. Boom. That's all she wrote. Let's give it a run. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And boom, y'all. Look at that. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, make sure you get one more look at the code. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.